should start recording. So, all right, so this is your program. It may show up like this simply because of the way it renders on a Unix system, but once you hit a button like reset or run or stuff, you'll get the board. So what this is a basic kind of game. So the red dot represents a fox, and this little brown dot represents a rabbit. These green dots represent, and these green blobs represent bushes. And this is a field. It's a bounded field. It doesn't work like Pac-Man, where basically if the rabbit goes up, he's going to end up over here. This is the edge of the board. He cannot move this way, right? Okay. Right. Now so the fox is, as you may surmise, the fox's goal is to chase down and eat the rabbit by just simply moving to the same square, right? So the program will run. And they each have an algorithm for figuring out what way they want to move, right? So the fox is hunting the rabbit. And let's see, we might actually get a dud this one. Let's see. Oh, nope. Oh, ooh, interesting. Oh, there we go. So 56 turns, it took 56 turns to eat the rabbit, to find and catch the rabbit, okay? And we'll run it again, and oh, very quick that time, 11 times. So the rabbit has a strategy for chasing down, and sorry, the fox has a strategy for chasing down and eating the rabbit. It's a pretty good strategy. The rabbit has a pretty crappy strategy, as we'll soon find out. But they have strategies. So the fox wins by basically occupying the same square as the rabbit. The rabbit wins by evading for 100 turns, okay? Your goal is to basically improve the rabbit's strategy so that it survives a whole lot more often and escapes. Now, if this was just simply a field with no bushes and infinite length, the rabbit, of course, would win because it could just simply find the fox and just simply run away from it forever. So there is an advantage to the rabbit, right, just inherently because it's trying to run away. You know, there is kind of an inherent defensive advantage there. So the way you and your partner will be graded on this one, because this is a pair project, is by running this grader which I provide you. So, and what it will do is that it will run a bunch of these games. Okay, so this is actually a pretty good random trial. So the code I gave you, this time I ran it, the rabbit escaped 4 times out of 300, or it escaped about 1% of the time. Okay. Now, the way you're giving, so you are graded based on the percentage of times the rabbit will escape, and I do 300 trials, okay? But it's curved. So rather than getting a 1%, you would actually get 10 points. The way our curve works is that your grade on this assignment is equal to the square root of your score times 10. So for instance, if you get a 25, the square root of 25 is 5, multiply that by 10, you get a 50. A 64 will net you a B, an 80. An 81 will net you a 90. So as you can see, the way this works is that it basically gives you a nice big boost to your scores on the lower end of things. Basically it's a way of making sure you guys don't get too disheartened from low numbers, because the strategy, because really in the beginning the strategy's just controlling the rabbit. It's not an ordeal. It's just I think you can probably write something pretty basic in about half an hour. That won't necessarily do too much, but it will do something, right? So, all right. Now there's a nice big PDF where I explain all these things. But let me go ahead and just show you what this looks like. This is the code. So the rule, I give you a bunch of code. It's a working program. You don't have to know anything about GUIs to make this work, or graphics. You don't have to know anything about the model view controller paradigm that's used to program this, although I'll explain that in a bit. This is the only class you modify, and that is the rule, the only rule. You can only modify this class. This is the only class you can modify. You can do anything you want to the rabbit, but only the rabbit, okay? So right now what I give you is public class rabbit extends animal, right? It has a constructor, right? And it extends an animal, so as a rabbit, that means since a rabbit is an animal, This means the rabbit will be able to do anything that's in the animal class, which we'll go over in a bit. It also has this int aside move, and this is like the where your work will be done, the vast majority of it. You might want to put some variables here, as you'll see. But the just int aside move, this is how the rabbit chooses a move. Anybody want to tell me what the rabbit strategy is and why it loses so often? Yeah. Yeah, I heard it, but it's, somebody said it's random. It means this is a function that chooses a random number between these bounds. Inclusive between these bounds. Between the minimum, an integer representing north, and then circling around clockwise to northwest. So basically one of those 8 directions says choose a random direction move, which statistically means it doesn't move anywhere, right? Because any move it makes will be eventually canceled out by any other move. So not the greatest strategy. Now, you've got a full working program. You're only allowed to modify this class, but you can look. And I highly recommend you do look at anybody else, any other class you want. So let's take a brief glance at Fox and what it does, right? So the author for Fox added variables, right? Have I seen the rabbit? Can I see the rabbit now, right? You know, keeping track of the distance to the rabbit, the direction to the rabbit, right? The current direction is currently going, right? The constructor really doesn't do anything too interesting other than choose a random current direction. It's decide move. He's very politely commented for us. It looks all around for the rabbit. Basically, it uses this function called look. By the way, this is the first thing I should mention. You'll notice that you've got a double equal sign here, actually, but it's kind of big. I've got font ligatures on my fonts enabled, so my font actually basically renders some stuff like the double equal sign as one big fat equal sign. And in fact, if I do a not equals, it will render it like this. So you also notice that you've got a less than or equal to sign. And that, again, it's rendering it just like that. It's just, it's a feature I find to be more readable. You might hate it, and I'm sorry if you do. I happen to like it. So, but it's something I really should mention straight out. So basically, it's saying that for all the directions, right, it's going to look through all the directions, right? So starting at minimum direction, which is a static variable that's in model, which we'll go over. In model.min direction, so it's going to go through up to and include the max direction, which is 7. It's going to look in that direction, and what look is that it looks, given a direction, it looks in that direction. Look is a function is a method you get from an animal. It's something all animals can do. And it says look in a direction and return what I see. And it looks in, and basically what you do is you look until you hit something, right? Bushes block line of sight, so if I see a bush, it returns a bush. If I see a rabbit, it returns an integer representing a rabbit. Now I don't know what number a rabbit is off the top of my head, but that's why we have static variables, model.rabbit. So basically, I don't know why. If look not equal, oh right, I switched it to a not equals. It was a double equals. So if look returns a rabbit in that direction, I know what direction the rabbit's in, right? Right. So now I've set can see rabbit now to have seen rabbit equals true. You can actually make an equal do an assignment like this, a chained assignment where basically this gets set to true and this gets set to true. So I now know what direction, and then also animals have a distance function where given a direction, it tells you how far you are from that thing, from something in that direction. What look will return is what are things? There's only really 4 things. There's foxes, rabbits, bushes, and edges. Edges are kind of, again, the whole edge of the board. And this will tell me how far I am. The next bit, if I have seen the rabbit, right, if I've seen it recently, not necessarily this time, but recently, then I just simply move towards its last known position, right? Because the rabbit can run away or dart behind something or something. So my strategy is if I've seen the rabbit recently, I'm just going to go to the last direction I've seen it, right? I'm going to go towards the rabbit. And so long as I'm not at the rabbit's last known position, I'm going to head towards there, okay? else, if I've made it to the rabbit's last known position, but I haven't seen it, then, okay, I chased the rabbit to where I last saw it. I don't see it anymore, so I'm going to start walking around randomly for it again. If I haven't seen the rabbit or lost track of it, I keep going in the current direction I'm going. Otherwise, I make a random move basically to go around an obstacle if I can't go that way. And if I can't go around an obstacle, then I choose a random direction to go in. That's the Fox's code in a nutshell. That's the Fox's strategy. And if it's stuck, right, just in case there's an edge case where it can't figure it out, like it's stuck, there is a direction 8. There's this final direction, which is represented by an 8, which is model.stay. Okay, everybody following go along so far? So animals can look in a direction. They can ask what is in a certain direction, and they can also, so they can look in a certain direction. They can ask also, can I even move in this direction? That's another method. Can I move in this direction? How far is something in that direction? What is in that direction? Those are the things that you can do with an animal. Okay. A lot of useful stuff, and I lay it out in your PDF file that I hand to you guys. So that's great as a quick reference. Is in this giant code class called model. So again, I mentioned this is a model view controller paradigm. That's a classic way that things are programmed for with GUIs. So there's these two classes here that you can completely ignore. I'm just going to briefly describe what they do now. The view literally provides a way for us to look at the program, right? This grid over here, this is the view, right? We're viewing what the model is the internal state of what's going on in the program, right? And the view allows us to look at that internal state, right? That makes sense? So its only job is drawing stuff. That's all its job is. The controller, that's this stuff down here. Basically, how quickly is the program running? Me hitting a button to reset the board creates a new board, right? You know, that's what the controller does. It allows me to basically say what I'd like to do, okay? And the model, again, represents the internal logic, where basically a lot of the interesting stuff happens. So you need to know exactly nothing about the way view and controller works. Rabbit Hunt is your main class. It's very boring. All it does is creates a new model, a new view, and a new controller. That's it. And then it just waits on, and then we just wait on controller to do some, controller to be hit in order to run, right? That's all it does. It says it's a 20 by 20 board. We create the field. We pass it, we pass it to the model view and controller, and create those things. That's it. Right? The Bush code is very uninteresting. It literally just simply is an object that exists, okay? So one question that I just want to get across, or one piece of information I just want to get across because there was some ambiguity, you don't actually ever move the rabbit. What you do is or the fox, what happens is that you complete the decide move function. And the rabbit basically informs the model what its move is going to be, and then the model moves it. That makes sense? Right? So you tell it, so the rabbit says, this is where I'm going to move, right? Okay, so those are the classes. So let me go now and look at model. So it's got a bunch of statics like number of rows, number of columns, right? They're finals, right? So you can't really change them, right? So north is 0, northeast is 1, east is 2, southeast is 3, and so on and so forth. Minimum direction is 0, max direction is 7, right? And then there's ints to represent an edge, a fox, and you can access all these by going capital M model dot. Okay? Finally, there's all these other functions here. There's really one that's really nice for you guys to use, okay? And that is actually I'll just use Control F, the turn method, which is a static method. And what this is that given this helps you makes your code direction agnostic. So given a direction, you can get another direction from that direction. So say you pass in south in this, all right? And you want to go the opposite direction of south. Well, you can, you pass in a direction, and then you pass in a number, and that's the number of 45 degrees turn clockwise you'd like to make. So you can pass in 4, okay? And so that will give you the opposite direction. So if you pass in south and 4, it will give you north. If you put in south and 3, it will give you northwest, right? Because you've got south, right, south, west, west, and northwest, right? I have to angle it differently because in reverse for you guys. So so that's how that one works. And it's just a way to basically say I want to go the opposite direction of something like that big scary fox. Although, even though it's a good starting strategy, a good strategy does not necessarily rely on running directly away from the fox. So I'll give you 3 hints. First, when you start out, you might want to look at the fox code, see what it does. Just simply get an idea of how to manipulate it, even if you come up with something stupid like, if I see the fox, run away. Okay, run exactly in the opposite direction. That won't get you very far because eventually you're going to hit something, but at least then you will know that your rabbit's responding to your commands. Second thing is that a really good strategy will take into account whether, is the fox really close to me? If the fox is really close to me, I can predict what's going to happen in the next couple of turns or what I need to do in the next couple of turns, right? Because as long as he can see me, he's going to just chase directly after me. And if the fox is further away, then I have time to plan and time to do interesting things. My third hint to you guys is figure out how that look function works, which is that you look in a direction. And actually, if you use the step, if we use the step over here, you can actually see the fox look, right? It's that kind of laser that it shoots out. And if your rabbit calls the look function, it will do exactly the same thing, okay? So you can see it look in a direction. And the question is basically when you call the look, and it's just simply skipping some of the frames. Basically, does this create blind spots? And if so, how can you exploit those blind spots? Okay? So those are my 3 things. So to get started on this, and basically this is what we're going to work on all of this class and all of the actual lab on Thursday. You want to split up into pairs. Now for each pair, you need to have a working laptop guys can program on between you. Okay? So every pair should have a working laptop that you can work on. Okay? So if you end up in a pair and there's not a laptop you can use, find a new group or something like that. So okay. And final addendum is that if you cannot rely on your laptop and you need a new laptop, talk to me. You can get a good laptop that will carry you through the rest of your degree for about $350. Right. And if you need to go lower than that, I have suggestions for even that.